In this video, we're going to talk about 5 of the fundamental trig identities. Today we're only going to talk about 5 of them, and it's very important that you know all 5 without even, having to do anything or trying to work anything out. You need to have these all 5 memorized, so pay close attention when you write them down and make sure that you're writing them down correctly each time. Okay, so we're going to start with the reciprocal identities, and these are fairly simple if you remember what we talked about in the beginning of trig, that sine goes with cosecant and cosecant goes with sine, cosine goes with secant, and tangent goes with cotan. Okay, so basically sine of theta is going to be equal to 1 over the cosecant of theta. Okay, and that means that cosecant of theta equals 1 over the sine of theta. Okay, cosine is 1 over the secant of theta, and secant equals 1 over the cosine of theta. And the same thing with tangent. Tangent's going to equal 1 over the cotan of tangent, or cotan of theta, and cotangent is going to equal 1 over the tangent of theta. So make sure that you have those copied down correctly and that you have those memorized. It's very important that you know these very well. Okay. The next one is the quotient identity. And the quotient identity we've already talked about a little bit. Basically, the tangent of theta is going to equal sine of theta over cosine of theta. Okay, this would be correction. Okay, that means that the cotan of theta is going to equal cosine of theta over the sine of theta, since cotan is the reciprocal of tangent. Notice that in the reciprocal identity there are 6 identities that you need to know. In the quotient identities there are 2 that you need to know. The next one is the Pythagorean identities. These ones are the most, well, not the most important, but the ones that you'll probably use the most out of all of these. Okay, so the Pythagorean identities, as this is focusing, oh my gosh. Okay, it's still focusing, but I'm going to continue to go. Basically, with the Pythagorean identity, if we use our unit circle, we know that this point here is cosine of theta, sine of theta. So what that means is that our x value, this distance here, is the cosine of theta. And then this distance here, our y value, is the sine of theta. So, in using our unit circle, we always know that the hypotenuse is 1. So that means that using Pythagorean's identity, that cosine squared of theta plus sine squared of theta equals 1. Okay, we can write cosine squared of theta either like this up here in parentheses, cosine of theta squared, or we can write cosine squared of theta. Commonly we write it this way, but they do mean the same exact thing. Okay? So this is the first Pythagorean's identity. There are 3 of them that you need to know. Okay? On your quiz, you're not going to have time to evaluate each of the 3 how we're going to do it below. So you need to have them memorized so that you can just spit them out really quickly. So basically what happens is we're going to find the other 2, we're going to take cosine squared of theta plus sine squared of theta equals 1, and we're going to divide every term by the cosine squared of theta. So if I write this out real quick, and if we divide each term by the cosine squared of theta, oops, you're going to see that cosine squared of theta over cosine squared of theta is 1, plus sine squared of theta over cosine squared of theta is going to be the tangent squared of theta. We got that by tangent squared of theta by using the quotient identity. And then 1 over the cosine squared of theta, that's going to be your secant squared of theta. We got that by using our reciprocal identities. Okay? So this is our second Pythagorean identity here. 1 plus tangent squared equals secant squared. Okay? Now to find the other one, we're going to divide everything by sine squared of theta. So in B here it says what happens if you divide every term by sine squared of theta. So we'll just go through this really quickly. So cosine squared of theta over sine squared of theta, that's going to equal cotangent squared of theta. And that's by using our quotient identities. Sine squared of theta over sine squared of theta is 1. And then 1 over sine squared of theta is cosecant of theta squared of theta. Okay? So that is our third Pythagorean identity. Now, here below, we're asked to list all 3 identities. It's really important that you list all 3 when you're asked what are the Pythagorean identities, because there are 3 and you need to know them quickly. So the first one is cosine squared of theta plus sine squared of theta equals 1. The second one is 1 plus tangent squared of theta equals secant squared of theta. And the third one is cotan squared of theta plus 1 equals cosecant squared of theta. Okay? So these are our 3 Pythagorean identities that you need to know. Okay. The next one that we're going to talk about is our odd-even identities. All right. So basically, we're going to go back and talk about the symmetry of our functions. And we know that our sine function is going to be odd. It's symmetrical about the origin, meaning we flip it over the x and the y, and it's still the same function. So what it means is if our function is odd, that means that sine of negative x is equal to negative sine of x. Okay, so this column here is actually our identity, okay? This whole column. Okay, so cosine function, that is symmetrical about the x-axis, meaning that it's even. And that means that the cosine of negative x is equal to the cosine of x. Okay. The tangent function is symmetrical about the origin. It is odd. So that means that the tangent of negative x equals negative tan of x. Okay. Cosecant is symmetrical about the origin. It is also odd, so cosecant of negative x equals negative cosecant of x. Our secant function is even. It's symmetrical about the x-axis. So that means that the secant of negative x equals secant of x. And then the last one, cotangent, is symmetrical about the origin. It is odd, so the cotangent of negative x equals the negative cotan of x. Okay, so when you're asked to list your odd and even identities, basically you're going to list what's happening in this column right here. Okay, let me put a box around that. If you want an easy way to remember it, just think all of them are odd except for cosine and the secant. So cosine and its reciprocal are both even, the rest of them are odd. Okay, and then if you go back to, I think it was in Unit 1 when we talked about odd-even functions, maybe it was Unit 2 in the beginning of the year, remember, if it is even, f of negative x equals f of x, and if it's odd, f of negative x equals negative f of x. So that's kind of where this is coming from as well. Okay. All right, the cofunction identities, this is the last one we're going to talk about today. And basically, this is just copied from your book. If you remember that complementary angles, 30 and 60, are two that are complementary. They add up to 90 degrees. Okay, so the cosine, or sorry, let's start with the sine. The sine of 30 degrees equals 1/2. That's the same as saying the cosine of 60 degrees equals 1/2. They both have the same value. 30 and 60 are complementary. So basically what we're saying here is the sine of angle A is equal to the cosine of angle B, where A and B are complementary angles. Okay, so in this example is just explaining it. 30 and 60 are complementary. The sine of 30 degrees equals 1/2. The cosine of 60 degrees equals 1/2. Okay, that means that the sine of 30 is equal to the cosine of 60 degrees. Okay. Values of a function at A is the same value as the co-function of B. Co-functions, okay, meaning like the CO in front, okay? Don't be confused, because now sine is going to go with cosine, secant is going to go with cosecant. These are always happen with complementary angles, okay? Complementary angles, they add up to 90 degrees, okay? So basically, this is our identity, and I have copied that straight from our book on page 447. All right, we're going to take a minute here, and we are going to do actually four examples on the last page here, okay? So it's really important that, first of all, you understand, focus, come on. Okay, it's really important that you understand that with these, where we're simplifying trig identities, there's not one way to always go about it. There's always going to, well, not always, but there's going to be different ways that you could do it. Sometimes it's shorter, sometimes it's longer, but there's not just one set way to do these types of problems, okay? So really keep that in mind as you're doing these. So if you do it one way and your neighbor or your partner does it another way, it doesn't mean that one of you is wrong and one of you is right. It just means that there's different ways to do them. Okay, so some people might see them one way, whereas another person might see it another way. So as I go through these problems, it doesn't mean that's the only way that you have to do it, because there are other ways that you can do it, okay? So let's look at number 1 really quickly. It says sine cubed of x plus sine x cosine squared of x, and you are asked to simplify this expression. Okay, so when I see this, the first thing I notice is that there's two terms, and we have a sine of x in both. So I'm going to take a second here and factor out the sine of x. Okay, when I have done this, I can instantly see that I have sine squared of x plus cosine squared of x. Anytime you're dealing with a square of those, you should automatically think of Pythagorean's identity, okay? So in this case, we're going to use Pythagorean's identity, and we know that the sine squared of x plus cosine squared of x equals 1. So this is going to be equal to the sine of x times 1, which is just the sine of x. So we've taken this trig identity, or trig expression, and simplified it down to the sine of x. Okay. All right, in number 2, if we look at this, it looks a little interesting. We have the secant of x plus 1 times the secant of x minus 1 over sine squared of x. Okay. The first thing that I think about when I look at this is the numerator is difference of squares. Okay, so one trick that you could do is go ahead and multiply your numerator. You know it is difference of squares, so we can multiply that out, and when we do, we're looking at secant squared of x minus 1 over the sine squared of x. Okay, so what you are thinking right now is the secant squared of x minus 1 is not one of our identities. But it's important to really know your identities, because you can recognize that that kind of looks like an identity that we know. Okay, it kind of looks like our trig identity, not our trig identity, our Pythagorean identity that says 1 plus tangent squared of x equals secant squared of x. Okay, if we rearrange this, we can have tangent squared of x equals secant squared of x minus 1. So just by knowing our trig identities and rearranging them, we can see that our numerator here is just tangent squared of x. Okay. Once we have done that, we now have tangent squared of x over sine squared of x. So what we need to do is we need to simplify this more, because we know that we can use our quotient identities, which says that tangent squared of x is sine squared of x over cosine squared of x, and that's all over sine squared of x. Okay, so right now we have a complex fraction, so we're going to go ahead and multiply that out, and we have our sine squared of x divided by cosine squared of x. Multiply that, because when we divide fractions we multiply by the reciprocal, 1 over sine squared of x. Our sine squared of x's are going to cancel out, and we're left here with 1 over the cosine squared of x. Using our reciprocal identities, we know that that is secant squared of x. Now some of you are going to want to leave your answer as 1 over the cosine squared of x. That is not going to be correct because it is not simplified completely. Make sure that you always simplify it completely. Okay? Alright, number 2. Cosine of x over 1 minus sine of x minus sine of x over cosine of x. Okay, with this problem, you basically are subtracting two fractions. So you really have to know your Algebra 1 skills and Algebra 2 skills to be able to do this, because you're adding to those skills the trig functions. Okay, so in this case we need to get a common denominator, and it will be cosine times 1 minus sine of x. So our first term I'm going to multiply by the cosine of x over the cosine of x. In my second term, I'm going to multiply by 1 minus sine of x. This is going to give us our common denominator. So whenever we do this, and I'm just going to kind of skip a step here or so, but we will get cosine squared of x minus sine of x plus sine squared of x. We get plus sine squared of x because we are distributing this negative to both terms, okay? Our denominator, I'm going to leave it in factored form, 1 minus sine of x times the cosine of x, okay? So what we can do now is, on our numerator, I'm just going to kind of rearrange it, because when we have cosine squared of x and sine squared of x, I know that that's similar to my Pythagorean identity, and it's easier if you can see that. So I'm going to rewrite this as sine of x plus, and then in parentheses I'm going to go ahead and put cosine squared of x plus sine squared of x. I haven't changed the numerator at all, I just rewrote it so it's a little bit easier to see exactly what's going on. Okay, so what we have now is negative sine of x plus 1, because cosine squared of x plus sine squared of x is 1, over 1 minus sine of x times the cosine of x. Okay? Now, oops, I'm sorry. Alright, so what we can do from here is we can kind of rewrite this a little bit easier. Some of you will probably be able to see that you can cancel here without rewriting it, but just for everybody here, I'm going to rewrite it as 1 minus the sine of x over 1 minus sine of x times the cosine of x. As you guys can see here, our numerator, 1 minus sine of x, is the same as this part right here, 1 minus sine of x. So those will cancel, and we'll end up getting 1 over the cosine of x. And using our reciprocal identities, 1 over the cosine of x is equivalent to the secant of x. So this would be our final answer. Okay? Alright, last problem here. number 4, we are asked to factor 1 minus 2 sine of x plus sine squared of x. Some of you guys will look at this and be very confused and not even want to try this, but it's really not that hard if we use some of the things we already know how to do. Okay, so the easiest way to do this would be to say, okay, well, let's let y equal the sine of x. So if we do that, we have 1 minus 2y plus y squared. This is a function or a quadratic that we know how to factor. Okay, some of you might have troubles without having the squared term in front, so we can rearrange it. Y squared minus 2y plus 1. So if we do that and we want to factor this, we would end up getting y minus 1 times y minus 1. Okay, which is the same as y minus 1 squared. Alright, now that's not our final answer because our final answer has to have the sign in it. So now we need to replace the sign back in there, and we would get sine of x minus 1 squared. This here would be our answer. Okay, it's very important that you know how to factor these trig functions. Okay, alright, these are the 6 or 5 trig functions that we talked about today: the reciprocal, the quotient, the Pythagorean, and the even and odd, and the cofunction. Okay, I highly suggest that you make a note card for each identity. Remember, your reciprocal identity, there are 6 of them. With your quotient identity, there are 2 of them. Your Pythagorean identity has 2. Or, I'm sorry, your Pythagorean identity has 3. Your odd-even identities, there are 6, and your cofunction identities include 6. Okay, you need to know these very, very well. You need to be able to use them without even thinking about it. Okay, you just need to know them and be able to spit them out very quickly at any given moment. Okay, it is a good idea to make a note card for each one, and it's a really good idea to study these every single day. Okay. You will be given a blank test where it just says reciprocal identities, and there's 6 blanks, and you need to fill them out. You're going to have about maybe 10-15 seconds per question. You need to know them that quickly. Okay, so you can expect that to come up pretty soon, maybe even tomorrow. Okay, make sure that you make your note cards and study them.